right, graphing for interval ratio variables. We'll probably focus more on graphs for interval ratio variables as they're probably a little bit more useful for our purposes. We'll talk about one kind called a histogram. One tricky thing about the histogram is it looks a lot like a bar graph, but there are some key distinguishing features. We'll also look at what's called a density plot, which is kind of a smoother version of a histogram. We'll look at a fun graph called a stem and leaf plot. And then we'll look at different ways to break down interval ratio variables by categories, side-by-side stem and leaf, stacked histograms, lots of different approaches here. Again, these are not discrete or categorical variables. The techniques that we saw before were strictly for categorical variables, whereas these techniques are for interval ratio variables. And again, we'll talk about some of the distinctions between histograms and bar graphs in a sec. Here is a histogram. This is of intelligence quotient scores. One thing that you can see here is that the bars aren't separated. This is a continuous scale of measurement, so you can see the bars are next to each other. We don't have distinct categories represented. And the bars actually cover a range of scores. The one that I'm pointing to goes from about 140 to 150. All right, you can accidentally do the wrong sort of graph here. You could do a bar graph instead of a histogram. And as you can see, it looks kind of weird. The reason why it looks like that is that it's graphing each individual score as its own category. So you don't really get much sense of the shape here. In the previous graph, you could see that most people tended to be between about 110 and 140, whereas this graph doesn't really transmit that at all. You can't really get that information from here. Here's a graph from an article that was focused on whether divorces declined following the World Trade Center attacks. You can see that on the left-hand side, they have the regular divorce rate. On the right-hand side, the divorce rate after 2001. They didn't include 2001 because that's when the attacks occurred. And you can see that there is actually a bit of a drop-off. Those second bars on the right-hand side, that's just showing what the average was of the previous years. And you can see that the average had gone down. All right, closely related to histograms are density plots. In general, for the purpose of this class, any time where I'm asking you to graph a variable like this, you can use a histogram, you can use a density plot, whatever your preference is, unless I specify to do a specific one. It transmits a little bit more information about the shape of the distribution, which is one of the things that I like about it. Here's a density plot of those same IQ scores. And again, you can see it's got the same information. You can still see, yeah, the biggest bulk of the scores is between about 110 and 140, but you can see how scores are spread out as well. So it's just a different way to represent those values. All right, here is a set of numbers that we'll go through a little bit of graphing with. This is percentages from people's grade percentages from a previous semester. So I've got their grade percentage, and I also have whether they attended or not, where 0 is that they rarely attended, 1 is that they regularly attended. And 1 is that they regularly attended. The type of graph we're going to talk about here is what's called a stem and leaf plot. What a stem and leaf plot does is it takes the values in the tens digits and it makes those kind of a marker for the category. And then the actual bars are the numbers in the ones digit. So you can see 4, a stem of 4 and a leaf of 4, that corresponds to the score of 44, the lowest score. You can see that the biggest category was in the 80s, 80 to 89. So reading this, there was an 80, an 81, an 82, an 83, 2 86s, 2 88s, and 2 89s. So another thing you can do is if you turn this way and you're looking at it on its side, it looks just like a histogram, or it's a backwards histogram. But you get some sense of the shape of the distribution from that as well. Now, had I, this is an example of how you can use a wrong graph for an interval ratio variable. I produced a bar chart here, but I'm actually graphing grade point average. One thing to note here is the shape of this distribution. Just take a look at how it's kind of symmetrical on both sides. We'll talk about that in a second, but one thing we can see is that we don't really understand the shape of a distribution if we graph it with the wrong technique. Here's what it looks like with a histogram. So with a histogram, we can see that there's like one person really down at the bottom, but with the bar graph, it looks just like it's part of the rest of the distribution. So always important to use the correct type of graph, otherwise you're going to get a result that isn't particularly meaningful. All right, just to review the differences between the histogram and the bar graph. Histograms for interval ratio variables. The frequency is a range of scores. That range of scores could possibly be 1, but it is always representing a range. And visually, there's no spaces between the bars. Bar graph, on the other hand, is graphing a nominal or an ordinal variable. It graphs the frequency or the percentage in a category, and visually, you will see spaces between the bars. If you accidentally use one of these with interval ratio variables, every existing score gets treated as a category, and it's going to be incorrect. All right, that's the end of part 3.